Welcome back to Research Solution. Today, we're diving into a fascinating topic in the world of research and science, meta-analysis. If you've ever wondered how scientists and researchers draw powerful conclusions by analyzing multiple studies, then you're in the right place. So, let's get started with our exploration of meta-analysis. Define meta-analysis. First things first, what is meta-analysis? Well, in a nutshell, it's a statistical technique used to combine and analyze the results from multiple studies on a specific research question or topic. The goal? To get a more comprehensive and accurate understanding of the subject matter by pooling data from various sources. Why meta-analysis matters. Host, you might be wondering, why is meta-analysis so important? It's because it allows researchers to increase statistical power. By combining data from multiple studies, researchers can detect smaller, but potentially meaningful, effects that might be missed in individual studies. Reduce bias. Meta-analysis can help identify and account for biases or inconsistencies across different studies, providing a more objective view of the evidence. Enhance generalizability. It can provide a broader perspective by including studies with diverse samples, settings, or methodologies, making the findings more applicable to various populations. The process of meta-analysis. Now, let's break down the steps involved in conducting a meta-analysis. Formulate a research question. Start by defining the specific research question or hypothesis you want to address through the meta-analysis. Literature search. Thoroughly search existing literature and identify relevant studies that meet your inclusion criteria. Data extraction. Collect data from each of the selected studies, including sample sizes, effect sizes, and other relevant information. Effect size. Calculation. Calculate effect sizes for each study. This quantifies the magnitude of the observed effects. Weighting and aggregation. Assign weights to each study based on factors like sample size or study quality, and then combine the effect sizes into an overall summary statistic. Assess heterogeneity. Examine the variability or heterogeneity among the study results. High heterogeneity may require further investigation or subgroup analysis. Publication bias analysis. Detect and address publication bias, which occurs when only certain types of studies are published, leading to an incomplete view of the research. Interpretation. Results. Finally, interpret the results, draw conclusions, and discuss the implications of the meta-analysis. Applications of meta-analysis. Meta-analysis isn't confined to just one field. It's used in various disciplines, such as medicine, psychology, education, and economics. Some common applications include assessing the effectiveness of a particular medical treatment, evaluating the impact of educational interventions on student performance, combining data from psychological studies to understand human behavior, studying the economic impact of government policies or interventions. Meta-analysis is a powerful tool that helps researchers make sense of a vast body of literature, providing more robust and reliable insights. It's a way to bring together the puzzle pieces of science to form a clearer picture of the truth. That's a wrap for today's video on meta-analysis. If you found this information valuable, don't forget to give us thumbs up, subscribe for more enlightening content, and hit that notification bell so you never miss an update. As always, feel free to leave your questions and comments below. Until next time, stay curious and keep exploring the world of knowledge.